Algebra 1, Section 3.3, equations with variables on both sides. Look, just going to look at a few examples. Here you have the measure of an angle is 5x minus 3. Its vertical angle is has a measure of 2x plus 12. Now, you may recall from a class that you took maybe in middle school or before that about vertical angles. It really doesn't matter. They're just trying to apply this very concrete, rote system of concept, if you will, of solving equations to other things, right? To maybe make it a little bit more real for you. At the end of the day, vertical angles are congruent, and we're going to set these things equal to each other. In fact, your algebra geometry, we will one day talk about the vertical angles theorem. But anyway, just right now, just know that these are equal quantities. It's the solving of the equations that we really want to be able to be experts at, okay? So I'm setting those two quantities equal to each other. Now, this is kind of just a different spin on what I said in the last video of, yes, you do need to do the opposite to the what's happening to the variable in reverse order, but first you might have to do something else. Well, but first in this case is get the variables together. It's not exactly combining like terms, but it's similar to that in that we're going to try to get all the variables on one side of the equation, and then we'll move the numbers to the other side of the equation. So most people in this situation would subtract 2x from both sides. Incidentally, there are 4 correct first steps here. If you would prefer to add 3 to both sides, that would move you closer to the answer. If you would prefer to subtract 12, that would move you closer to the answer. Most people would not choose this, but subtracting 5x from both sides would bring it over to here, and now you'd have negative 3x. That would bring you closer to the answer. But most people are going to want to choose to get the x's together first and keep the coefficient positive. So most people in this situation would choose to subtract 2x here. So since that's what most people will choose, that's what I'm going to do. That makes this 3x minus 3 is equal to 12. Then you can add 3 to both sides and divide by 3. X equals 5. Okay, so again, once we get the variables from the original, once we get the variables together on one side of the equation, then it's a lot like section 3.1. This one says you can buy a skateboard. You see how they're trying to make this real for you? Hey, it's skateboards, man. Bro, we're talking about skateboards. It's real now. Anyway, you can buy. Kind of messed up my speech there. You can buy a skateboard for $60 from a friend and rent the safety equipment for $1.50 per hour, or you can rent all the items you need for $5.50 per hour. How many hours must you use a skateboard to justify buying your friend's skateboard? Okay, so one of those models is you can spend $60 up front and then only pay $1.50 per hour. The other one is just pay $5.50 per hour. See where I get those expressions? And we're setting them equal to each other because this will be kind of the break-even point, okay? So we can solve this. You would subtract 1.58 from both sides. By the way, you could multiply through by 10, see my previous video, but I think I'll just go ahead and subtract 1.5 from both sides. It's going to make it a whole number anyway, 4h. So then h would be equal to 15. I do like you to flip that around, and that's what it is. So 15 hours. After 15 hours, let's think about this now. So 15 hours is the break-even point. After 15 hours, you're going to be spending more money here, right? Because you're still spending $5.50 per hour. Less than 15 hours, you're spending more money here because you paid all that money up front, right? So it really depends on how long you're going to go skateboarding. 15 hours. Okay. Now, next example is of great importance. Solve. Okay, so here we go. This kind of brings two things together. We got to distribute, and then we're going to have variables on both sides. So let's go for it. Negative 2 times 2y would be negative 4y. When we distribute here and then there, that would be plus 4. Then what we would do is probably add 4y to both sides, no matter which side of the equation. Incidentally, no matter which side of the equation you're looking at, probably your next step is to add 4y to both sides. And what do you get? 4 equals 4. Now let me ask you a question. How often is 4 equal to 4? Always. 4 is always equal to 4. These are equivalent sides of the equation. Each of these sides of their equation is equivalent, right? Always. And that would be true up here. It was actually true up here. To say that differently would be to say that any value for y that you plug in will work. If you don't believe me, try it. Pick a few different numbers. Pick 0, pick 5, pick -2, pick a million. It will always make these things true, okay? So basically, we have a situation where the answer could be any real number or all real numbers. The way we say this in algebra, though, is we want you to say identity. Remember the identities that we talked about in the previous chapter? Yeah, those are identities. And that kind of identity. You think self. 4 equals 4 is an identity. It's itself. Okay, so we want you to say identity. Now, look at B, part B here. Again, you don't know any better, right? You're just going about it, and you see, oh, we got combined like terms here. So Z minus 7Z would be -6Z plus 10. And then if you add 6Z to both sides, you're going to get 8 equals 10. The variables just dropped off of both sides of the equation. But there's a very significant difference between this one and the last one. The last one, 4 equals 4, is a true statement. This one, 8 equals 10, is a false statement. By the way, what if you didn't even realize that you had an issue yet and you just kept on going? Okay, you could subtract 8 from both sides. You would get 0 equals 2. At some point, you're going to realize that you've got a false statement on your hands. So think about this now. For what values of Z does 0 equal 2 or does 8 equal 10? None. There is no solution here. We were trying to find a solution and all we got to was a false statement. So in this case, you say no solution. Now let me be really clear and then we'll end the video. You either get an answer, x equals 5, y equals -9, z equals 2, or you get an identity, or you get a no solution, okay? We were going about this with a pure heart trying to get an answer, and we ended up getting a true statement. That's an identity. We went at this one honestly, right? We thought we would get an answer. We just didn't. We ended up getting a false statement. That's when you say no solution. Absent of that, remember the first example we did here, you get an answer, and it's x equals 5, okay? Now here's why I bring that up. Because we could have checked this problem right here. 5 times 5 minus 3, wondering if that's equal to 2 times 5 plus 12. And here's 25 minus 3, that would be 22. Here's 10 plus 12, that would be 22. It checks. Not a year goes by where I don't have somebody go, identity. If you write identity after a check, you fundamentally misunderstand what an identity is. This isn't an identity. This is x equals 5. You checked x equals 5, and it turns out that it works. So yes, you get the same thing. It's not identity. Identity is when you're actually working out the equation, trying to solve it, and you get a true statement. You hope that you're going to get a true statement when you check something. This is not an identity. All right, thanks for tuning in.